Hello guys, I am Ranjan Mishra from Revolution Physics Ghaziabad and we are going to derive the refraction formula today. Okay, the formula that is a foundation for deriving lens maker formula and lens formula. So it is very important formula. Okay, let's derive refraction formula. Let's have a convex surface. Remember that we are deriving here for a convex surface, but the formula will be valid for concave and convex both. Here we are going to derive for convex surface. Okay, this is a denser medium having the effective index mu2 and this is a rarer medium having the effective index mu1. Let object be at point O and light fall on the surface. If there is no medium change, then light might have passed from this path, but as medium is changing, it will bend towards normal. Okay, this is the normal, so light will bend. Light will bend towards the normal and final image is formed at I. Okay, this is O and let's consider it as a P and draw a perpendicular from point A on the axis. Now this is offset, so this will be the object distance U and this is center of curvature, so it will be R, and this is image, so it will be V. This is the simple diagram. Now the main equation we are going to use is Snell's law. What is Snell's law? Mu1 sine I must be equal to mu2 sine R. But for small angles, we can neglect sine, and this is also for tan theta. We will use in this equation. So you can write mu1 I must be equal to mu2 R. Now let us have I. What is I? Incident ray make angle I with the normal, so it will be I, and refracted ray make angle R with the normal. Okay, now we know that, let us say it alpha, this angle at beta and this angle at theta. Now we know that exterior angle must be equal to sum of interior angles. This is exterior angle and alpha and beta is interior angles in triangle AOC. In triangle AOC, we can write angle I must be equal to angle alpha plus angle beta, angle alpha plus angle beta. And what is angle alpha? This is alpha in triangle OAM. In OAM, in this triangle OAM, tan alpha will be AM upon OM. It will be AM upon OM. Okay, plus beta in triangle ACM, tan beta will be AM upon MC, AM upon MC. Okay, now in triangle AIC, AIC, beta is exterior angle and alpha, R and theta is the interior angles. So you can write angle beta will be equal to angle R plus angle theta. Now we can write angle R as angle beta minus angle theta, and beta is in triangle ACM, AM upon MC. Beta is AM upon MC minus theta in triangle AIM. Tan theta will be AM upon MI, AM upon MI. Okay. Now let's have a assumption, because this lens is very small, because we consider the spherical surface very thin, we can consider OP as OM, and that is equal to minus U. MC can be considered as PC, and that is nothing but R, and MI can be considered as PI, and it will be V. Now put the values. mu1I, that is mu1, and what is I? I is AM upon OM, AM upon OM plus AM upon MC, AM upon MC equal to mu2 R. What is R here? AM upon MC, AM upon MC, it is AM upon MC minus AM upon MI, AM upon MI. Now see, AM is common, AM, it will be cancelled out, and rearrange it. It will be mu1 upon OM plus mu1 upon MC equal to mu2 upon MC minus mu2 upon MI. Now take mu1 upon MC in other side and mu2 upon MI in left side. It will be mu1 upon OM plus mu2 upon MI, that will be equal to mu2, and this is minus mu1 upon MC. Now let's see, OM is equal to minus U, and MI is equal to V. So put the values, mu2 upon V, because this is positive and OM is negative, so I am putting minus mu1 upon U, and that is equal to mu2 minus mu1 upon MC. MC is R. Okay, this is the final result, and this is called refraction formula. Here we have derived the formula for convex surface, but this is valid for both concave and convex surface, and this formula is very important for deriving lens formula and lens maker formula. Okay. Hello guys, I am Ranjan Mishra, Revolution Physics, Ghaziabad. Today we are going to derive lens maker formula and lens formula. That is the topic included in refraction by lenses. This formula is very important for both point of view. In term to examination, either there will be a numerical on it, or derivation on it, or both. Okay, so this topic is very important. Okay, let's derive the lens formula and lens maker formula. Okay, I have taken a lens. Let's have a lens. It is a convex lens. Here, this lens is made of two surfaces. One surface is this and another surface is this. Let A, B, C, D. One surface is ABC and another surface is ABC. There is two surfaces, and for diffraction from a spherical surface, we have already derived a formula mu2 upon V minus mu1 upon U equal to mu2 minus mu1 upon R. Mu is a refractive index in which image is formed. Mu1 is refractive index in which object is placed, and R is radius of curvature of the spherical surface. Here there is two spherical surface. Let the R1 be the radius of curvature of ABC and R2 be the radius of curvature of ADC. Okay. Now let us consider object is here and the medium of object is mu m. I have written m because it is refractive index of medium, and refractive index of lens is, let us consider it is mu l. Okay. Now if a light fall on it, first it will be refracted from ABC, the first surface. Let it make, if there is no second surface, then it must make an image. Let it be I1. Okay. Remember that this image is not formed in this medium. It is in the lens, because the final image will be like this after the refraction from the second surface. It will be the final image. The key point you have to remember in this derivation, that I1 is not in the mu m medium. It is in mu l medium. It is within the lens. Okay, this is the key point. If you get this point, there is no problem in deriving the formula. Okay, let it is O, this is I, and this is I1. Okay, this distance is U, and this distance is V, and this distance is V1. Okay, now let me explain. OB is approximately equal to OD, because we are considering lens is thin. It is a thin lens. Okay, DI can be treated as BI. Okay, and that will be equal to V. This will be equal to minus U, and DI1 approximately equal to BI1, and that is equal to V1. We have taken the values. Now first, refraction from the first surface. Refraction from the surface ABC. Then where is the image by the surface ABC? It is in medium mu L, and this is V1. So we will write mu L upon the image is V1. It is V1 minus object distance. Object is OB, that is, it is in mu M, and that is U. I have written OB or OD, that is equal to U. Okay, and that will be equal to mu2 minus mu1, that is mu L minus mu N upon R1, because the radius of curvature of surface ABC is R1. Let's say this equation number 1. Now refraction from second surface. Refraction from surface ADC. Now the final image in medium mu M. Here this medium and this medium is same. We take medium in which image is formed. So final image is formed in mu m and it is V. This is V di, that is V, minus mu L, because object, this image I1 act as an object for surface ADC and it is in medium mu L and its distance is V1, and so now mu m minus mu L upon R2, let it be 2, equation number 2. Now add equation 1 and equation 2. See here is mu L upon V1 and here is minus mu L upon V1. Cancel out. Here is mu1 upon V and mu1 upon U. So result will be mu m upon V minus mu m upon U. Okay. In right side, mu L minus mu m, and here is mu m minus mu L. Here is mu L, here is mu m. If I take mu L as common, it becomes negative, and I can take mu L minus mu m as common, and it will be 1 upon R1 minus 1 upon R2. Now mu L is common here, mu m, and it will be 1 upon V minus 1 upon U, and that is equal to mu L mu m 1 upon R1 minus 1 upon R2. Now if I divide this mu m in this side, what will get? It will be 1 upon V minus 1 upon U equal to mu L upon mu m minus 1 and multiply by 1 upon R1 upon 1 upon R2. This is first equation. This is equation number 3. Let's say equation number 3. Okay. Now, if I take this object at infinity, if I take U at infinity, then final image will be formed as focus. So this equation becomes 1 upon F equal to mu L upon mu m minus 1 and 1 upon R1 minus 1 upon R2. This equation is known as lens maker formula. This is lens maker's formula. Okay. This is called lens maker formula and name it as equation number 4. Now from equation 3 and equation 4, right hand side is equal. So from equation 3 and 4, we can say that right side is equal, so left side will be equal, and it comes 1 upon F equal to 1 upon B minus 1 upon U. This is called lens formula. Okay. This is called lens formula, and this is the whole derivation. You can take a screenshot. Total derivation of lens maker formula and lens formula. Okay. Thank you. Hello guys, I am Ranjan Mishra and today we are going to derive formula for combination of lenses. When more than one lenses are in contact, what will be the equivalent focal length and what will be the equivalent power? We are going to discuss here. Okay, let's see the situation. Let's have a lens. I am taking here a convex lens. It is a convex lens having focal length f1 and it is in a contact with another convex lens having focal length f2. Okay, let it be the axis and object is placed here. Okay, as we have seen in derivation of lens maker formula, two surfaces we are working, first refraction from first surface and then refraction from the second surface. In the similar way, first we will take first lens and it will make an image like this. This is the ray and it making an image, let it say I1. Okay, and this image will act as a object for the second lens and final image will be formed as here. Let it be I and its distance is V. Okay, simple concept. Here is the object and it will be U. Okay, object distance, first image distance and second image distance. Okay, now let us write the equation. Refraction from first surface, refraction from first lens. Okay, first lens, let's say it L1 and L2. First lens L1, then equation will be 1 upon V, that is image is V1 for the first lens. It will be 1 upon V1 minus 1 upon U equal to 1 upon F1. Equation number 1. We are using just lens formula, 1 upon V minus 1 upon U equal to 1 upon F, where V is image distance, okay, U is object distance and F is focal length. F is focal length. This formula already we have derived. Okay, now refraction from second surface. Refraction from second lens. Okay, second lens, let it say L2. Now the final image is at V, so it will be V and object. The first image will act as an object, so it will be 1 upon V1 and that is equal to 1 upon F2. That is equation number 2. Let us add two equations. Equation 1 plus equation 2. It will be 1 upon V1 minus 1 upon U plus 1 upon V minus 1 upon V1 equal to 1 upon F1 plus 1 upon F2. V1 cancel out and it is 1 upon V minus 1 upon U equal to 1 upon F1 plus 1 upon F2. Equation number 3. If we use equivalent length in place of this lens, then let us say this is equivalent length. I am using here a lens. It have a focal length F. Same object. It will go like this and position of image is same. Okay. So it will have it will have the equation like this: 1 upon B minus 1 upon U equal to 1 upon F. Let us take equation number 4. So from equation 3 and 4 you can see that left hand side is equal, so right hand side will be equal. So you can write 1 upon F1 plus 1 upon F2 equal to 1 upon F. This is the final result. That is when two lenses are in contact, then the resultant focal length is given by 1 upon F1 plus 1 upon F2. And power is defined as 1 upon F. So resultant power will be P1 plus P2 dot Pn, and resultant magnification will be M1 into M2 dot Mn. These are the derivation. Okay, thank you. Some numericals on Lens-Weger formula and lens formula. That is the question: a convex lens made of a glass of refractive index 1.5 is dipped in term. A medium of refractive index 1.65 and a medium of refractive index 1.33. Question is, will it behave as a converging lens or diverging lens? And second, how will its focal length change in two media? Okay, simple. Now we have lens maker formula. It was 1 upon f equal to mu L, that means medium of lens, upon mu m, refractive index of medium, minus 1 into 1 minus R1 minus 1 upon R2. Okay, now see the situation. This term 1 upon R1 and 1 upon R2 is decided by the construction, because these are the radius of curvature. So because of change in medium, this term will not change, it's for sure. Okay, see here, this is medium of lens and it is given 1.5, and this is mu m, medium in which lens is immersed or dipped. Okay, and this is f. F, we know that focal length, it is positive for convex lens. Okay, it is positive for convex lens, and that is called converging lens. Another name is converging lens. It will be positive and it will be negative for concave lens or diverging lens. Okay. Now see the term here. This term is fixed and here is mu L upon mu n. If this ratio mu L upon mu n is greater than 1, then this whole term will be positive, and so f will be positive and it will behave as a convex lens. If this ratio mu L upon mu m is less than 1, then this is less than 1 and this is 1, this term becomes negative. This term becomes negative, and so f becomes diverging lens or concave lens. Okay, now see the first case. In first case, it will be 1 upon, let us say f1, mu L is 1.5 and refractive index of medium is 1.65. 1.65 minus 1 and 1 upon R1 minus 1 upon R2. See here, this ratio is less than 1 because 1.5 is less than 1.65. So this term will be negative. So in this case, lens will be concave. Concave means diverging lens. Okay. In second case, the refractive index is 1.33. In this case, the medium of lens is 1.5 and refractive index of medium is 1.33 minus 1 and it is 1 upon R1 minus 1 upon R2. Now this ratio 1.5 upon 1.1 is greater than 1, so F2 will be positive, so lens will be convex or converging lens. Okay, simple question. In second part, how will its focal length change in two media? Okay, let's divide it. If I divide it, what will happen? It will be F2 upon F1 it will be 1.5, 1.65 minus 1 upon 1.5 minus 1.33 minus 1. Now, after solving this, we will get this value as 4. So we can say that F2 will be 4 times F1. Okay. In second time, when refractive index becomes 1.33, then focal length becomes 4 times compared to first case. Okay. Another question on lens formula, lens maker formula. Okay. Here is the question: the radii of curvature of faces of a double convex lens are 10 centimeter and 15 centimeter. Okay. If focal length of lens is 12 centimeter, find the refractive index of material used. And we know that we have formula 1 upon F equal to mu L upon mu M minus 1 upon R1 minus 1 upon R2. Here second medium, that is medium, refractive index of medium is not mentioned. So by default we will take it as a air and mu M will be 1. Okay. Now given focal length is given, it is 12 centimeter. R1 is given, it is 10 centimeter. And length is like this. If R1, this is R1, this is R2, it will be positive and it will be negative because of it is in the left side. So R2 will be minus of 15 centimeter. Okay. Now apply the formula. 1 upon F, that means 1 upon 12, and refractive index is not known to you, that means it will be mu L minus 1 and it will be 1 upon 10 and minus 1 upon 15. Okay, it becomes positive, it will be 1 upon 12 mu L minus 1 and it will be 30 and it is 3 plus 2. Okay, and it is 1 upon 12 mu L minus 1 equal to 5 upon 30, 5 6 and 6 2 ja. Okay, that is 1 upon 2 equal to mu L minus 1. So mu L will be 1 by 2 plus 1, it will be 3 by 2. Simple question and simple solution. Okay, thank you. Here is the next question. Question is, a biconvex lens has a focal length 2 by 3 times the radius of curvature of either surface. Calculate the refractive index of lens. Very easy question. It is a biconvex lens. That means the radius of curvature will be same. That is, magnitude of R1 must be equal to magnitude of R2, and let us say it R. Okay. Also given focal length is 2 by 3 times. That means F is 2 by 3 times R. That means R upon F must be 3 by 2. Okay. Now we have formula, lens maker formula, 1 upon F equal to mu L upon mu M minus 1 and 1 upon R minus 1 upon minus R. Okay, 1 upon F, and because medium is not mentioned here, by default we will take mu M as air, it will be mu L minus 1 and it becomes 2 upon R. Okay, now take R in left side, it will be R upon 2F equal to mu L minus 1. Okay, and R upon F equal to 3 by 2. That means 3 by 2 into 2 equal to mu L minus 1. So mu L will be equal to 3 by 4 plus 1. It will be 7 by 4. Simple question, simple solution. Thank you. Here is next question. Find the radius of curvature of convex surface of a plano-convex lens. What do you mean by plano-convex? That means one surface is plane and second surface is convex. Okay, whose focal length is 0.3 meter. That means F is given 0.3 meter. And as we know that the plane surface have radius of curvature infinite. Okay, and let it be R. It is unknown. Okay, and material of the lens is, that means mu L is 1.5. Just put the value. We have the lens formula 1 upon F equal to mu L mu M minus 1 upon R1 minus 1 upon R2. Okay. Focal length is given 0.3 meter. That means 1 upon 0.3. And mu L is 1.5. And because medium is not mentioned, by default we take it as a air. And 1 upon R. R is 1 upon infinity. And minus, it will be minus of R. Okay, let's remove the decimal. It is 10 by 3 and it will be 1.5 minus 1.5, that is 1 by 2, and 1 upon infinity 0, and it becomes 1 upon R. So 1 upon R will be 20 by 3, 10 by 3, and this is 1 by 2, 1 upon R. So it will be 20 by 1 upon R equal to 20 by 3. So R will be 3 by 20 meter. Okay, 3 by 20. A converging lens has focal length of 20 centimeter. Okay, that means F is given 20 centimeter and it is converging, that means convex lens in air. It is made of material of refractive index 1.6. That means mu L is given 1.6. If it is immersed in a liquid of refractive index 1.3, that means mu M is given 1.3. Calculate new focal length. Simple question. Let it is initially F when there is air. So mu L upon mu M minus 1 equal to 1 upon R1 minus 1 upon R2. When there is air, its focal length is 20 centimeter. Okay, we will put in last, let it F1. So F1 equal to mu L. Mu L is 1.6 minus 1 and it is 1 upon R1 minus 1 upon R2. Then it is equation number 1. Now when it is immersed, okay, when it is immersed, okay, then let it be focal length F2, then it becomes 1.6 upon 1.3 minus 1 and 1 upon R1 minus 1 upon R2. Let's solve it. 1 upon F2 will be 1.6 minus 1.3 upon 1.3 into 1 upon R1 minus 1 upon R2. Okay. It comes as 0.3 upon 1.3 into 1 upon R1 minus 1 upon R2, and it will be 1 upon F2. Let's divide. Okay. Let's divide both equations 1 and say it as a 2. 1 upon 2. So it becomes F2 upon F1, F2 upon F1, and equation 1 is here 1.6 minus 1, it will be 0.6. Okay, and here is 1 upon R1 minus 1 upon R2, here is also 1 upon R1, 1 upon R2, it will be cancelled. So here is 0.3 into, it becomes 1.3. We can remove the decimal, it will be 2. So F2 will be, it is 2.6 times F1, and F1 is 20 centimeter. It is 20 centimeter and it is 2.6. So it is 20. So 40 and 12, it becomes 52 centimeter. So the new focal length will be 52 centimeter. Okay, that's simple question. Hello guys, I am Ranjan Mishra, and today we are going to derive minimum deviation produced by prism. This is the prism, you can see. From this prism we will do experiment in our lab for minimum deviation. Okay, now you are derive here formula for minimum deviation. Okay, let us see. It is a prism. I am making diagram by running hand, so you have to manage A, B and C. This is a prism. This is the incident ray. This ray is incident on the prism. Okay, and this is normal at point of incidence. If there was no prism, this light must go like this without deviation. Okay, but because a medium is present, another medium is present, and it is denser, it will bend towards the normal. This is normal, and this light bend towards the normal. That means at this point, this is the deviation. Okay. Now, at this surface, you can see, let us draw first normal. This is the normal. If there is no medium change, this light must go like this. But because it going from denser to rarer, it will bend away from the normal. The actual path should be like this, in this way, but it bend, this is the normal, away from the normal. That means in this case, deviation is this. Now, we have to calculate the deviation, the actual path before entering the prism was this, and this ray is going out. So, if I extend this line, this will be the deviation, total deviation produced by the prism. Okay, this angle, this is the normal and this is incident ray, so this angle we say as incident angle. Okay, and this angle is called emergent angle. Okay, This is refracted angle for this surface, we say it R1, and this is incident angle for this surface, we say it R2. Okay. Now let the name of the ray P, Q, R and S. Okay. You can see the deviation produced. If this angle is I, then alternate interior angle must be I. That means this angle must be I. This is I, so this angle also be I. But deviation produced by this surface is only this. This is the deviation produced by this surface, that is surface AB. So if I calculate total deviation, I have to add deviation produced by this surface and deviation produced by this surface. At surface AB, deviation produces this angle. This is Q, and let's see, say it PQRS, say it M, and this as N. Okay, now this deviation is I minus R1. Okay, this total angle is I and this is R1, so this angle will be I minus R1 plus, see at the surface AB, this angle is this total angle is E, but this is R2. Okay, this is R2, so it also be R2, this angle will be R2. So deviation produced at this surface is this only, so it must be E minus R2. This is the total deviation produced by the prism. Now just rearrange it. It will be I plus E minus R1 plus R2. These are all angles. Remember this. I, R1, R2, E, all are angle. I am not using this sign. Okay, but you have to check it. These are the angles. Let's set this is equation number 1. Okay, now see, this is normal, so this angle will be 90 degree, and this is also normal, so this angle also be 90 degree. So if I take a quadrilateral A, Q, N and R, let us take in quadrilateral AQ, N, R, AQ, N, R, this angle is 90 degree, this angle is 90 degree. So angle A, this angle and this angle Q and R, angle Q and R must be equal to 180 degree, because in quadrilateral the sum of all angles must be equal to 360, and this sum up to 180. So angle A and angle Q and R must be 180 degree. Okay, let's see equation number 2. Now in triangle Q and R, R1 plus R2 plus this angle must be 180 degree, because sum of all angle of a triangle must be 180 degree. So angle R1 plus angle R2 plus angle Q and R must be equal to 180 degree. That is equation number 3. Now see, Q and R in equation 2 and 3, here is Q and R, and in right hand side this is 180 degree. So angle A must be equal to angle R1 plus R2 because both equations are equal. In right hand side there is 180 degree, here is also 180 degree, and this angle is common. So angle A must be equal to angle R1 plus R2. Okay. So from equation 2 and 3, angle A must be equal to angle R1 plus angle R2. Okay. Let's see it, equation number 4. Okay. Now, here is delta equal to I plus E and this is R1 plus R2. Now, we apply a condition for minimum deviation. For minimum deviation, R1 must be equal to R2. Okay, and this is R. I say it R. Okay, and I must be equal to E. We applied the condition for minimum deviation, R1 must be equal to R and I must be equal to E. Okay. By this condition, if apply here, delta becomes delta M and we can say this is 2I because I and E are equal. So I can write this as 2I and minus R1 plus R2. R1 plus R2 is A. From this, if I apply both condition here, R1 plus R2 is A, R1 plus R2, so I can write it A. From where here we get I, angle I equal to delta M plus A by 2. This is equation number 5. And from equation 4, because R1 and R2 is equal and this is R, it becomes 2R. So R will be A by 2. Equation number 6. Okay. Now we know that Snell's law, mu1 sine I. Let the refractive index of this medium is mu1 and refractive index of prism is mu2. Okay. Then, so we can say that from a Snell's law, mu1 sine I must be equal to mu2 sine R. Okay, mu2 sine I must be equal to mu2 sine R. Now do it. Now, here we have mu1 sine I equal to mu2 sine R. Now do on the next page. Okay, here mu1 sine I equal to mu2 sine R. Okay, but for a small angles, we know that sine theta can be written as theta. So it will be mu1 I equal to mu2 R. Okay, see here I is delta M A upon 2. So mu1 in place of I, you can write delta M plus A by 2 equal to mu2 and R is, you can see here, R is A by 2. So it is A by 2. Okay. Now this 2 and 2 is cancel out and mu1 delta M plus A equal to mu2 A.
Now take A in left side and mu1 in right side. You can write delta m plus A by A equal to mu2 upon mu1, and that can be written as mu21. So it becomes delta m upon A plus 1 equal to mu21. Now take 1 in right hand side. It becomes delta m upon A equal to mu21 minus 1. Now we can write delta m equal to A mu21 minus 1. This is the derivation for a minimum deviation of a prism. Okay. Now we can draw graph between a angle of deviation and angle of incidence. Here will be delta and here will be I. This graph is like this. This will be minimum deviation. Okay, this will be the minimum deviation, and this is all about prism. Okay, now we have derived the formula and drawn the graph. Okay, thank you.
Hello guys, I am Ranjan Misra and we are going to discuss compound microscope. Before we discuss compound microscope, you have to learn the simple microscope that we already discussed on the channel, and I have given the link in the description box. You can see the simple microscope. After that, please see this video. Okay, by simple microscope or by compound microscope or by telescope, in all three instruments, basically we increase the visual angle. Visual angle is angle subtended at our eye. We increase the visual angle. Okay, now let us understand and derive the magnifying power for compound microscope. Okay, in compound microscope there are two lenses, two convex lenses. One lens is smaller and other lens is larger. Okay, one lens is smaller and other lens is larger. In this side we see the image, so it is called eyepiece. Eyepiece will be larger, and this is called objective because object is placed here. In this side object is placed, so we say it objective. The basic function, the basic strategy we can say for microscope and telescope both, we make image from this lens in focal plane of eyepiece. Simple, we make image of objective lens in focal plane of eyepiece, and eyepiece make the image in same direction as virtual image and enlarged image. As we know that if an object is placed between optical center and focus, then image will be enlarged and virtual. This is the concept that is utilized. That is, this lens is always a simple microscope that we have discussed already. Okay, now let us first draw the ray diagram. Let's have an object here. Let's have an object here. Then see the trick. First make the image in this plane and then start in reverse direction. Let it be this. First image, first line, and it will go like this. Okay. Now second image, second line, let it pass like this and go like this, and the final image will be formed here. Okay, this final image can be anywhere. This is VE. This can be from D to infinity, anywhere. Okay, this is the basic ray diagram. Okay, just now. Good. This is the object, that means it is H, and this is the image, first image. Say it H dash and make this as a theta. Okay, then this is UE, because this image will act as an object for this lens, so it will be UE, and this is image B naught for the first lens. Okay, simple concept. Now see the theta, tan theta, that will be theta will be equal to perpendicular H dash upon UE, the first theta. And from simple microscope we know that theta naught is H and this is D, so theta naught is H upon D. Okay, now the main purpose of this instrument, compound microscope, is to increase the angular magnification, and so we will calculate the magnifying power. First derivation is magnifying power. And it is defined as visual angle with instrument, that is theta. Okay, and visual angle without instrument, that is theta naught. So magnifying power will be theta upon theta naught, and we have already calculated theta and theta naught. So put the value MP. Theta is H dash upon UE upon theta is H upon D. Okay, so it will be H dash upon UE into D upon H. Now we can write that MP equal to H dash upon H and D upon UE. Okay, and from simple microscope already we know that H dash upon H equal to minus V upon U. Okay, so we can put here MP equal to minus V upon U and D upon U. This is the final result, and now we will discuss for two cases, far point, and now we are going to discuss two conditions for far point and for near point. Okay, far point means the final image. This is the final image VE. If this VE is formed at infinite, okay, if VE is at infinite, we have formula 1 upon VE minus 1 upon UE must be equal to 1 upon FE. In this case, it will be minus infinite because image is formed in left side and object is also in a left side, so it will be minus UE and that is equal to Fe. 1 upon infinity is 0. From here UE will be Fe. Okay. In this case, magnifying power will be V upon U into D upon Fe. Okay. And tube length, see the tube length, the distance between the objective lens and the eyepiece is called tube length, and that is called L. L is what? V plus UE. In this case, L will be V plus Fe. Okay. This is the case when final image is formed at infinity. Okay. This is called far point. That means for far point, the magnifying power will be minus V upon U D upon Fe. And when final image is formed at least distance of distinct division, like if final image VE is formed at minus D, then we can say that 1 upon D. I am using the same formula, and it becomes minus 1 upon D minus of 1 upon U equal to 1 upon Fe. From here 1 upon UE will be equal to 1 upon D plus 1 upon Fe. But in magnifying power, D upon U is there, so multiply both sides by D. Multiply both sides by D, then we will get D upon UE equal to 1 plus D upon Fe. And magnifying power is this, minus V upon U D upon UE. So MP, magnifying power, will be minus V upon U into 1 plus D upon Fe. This is the magnifying power for near point. This is called near point. That is, this has been discussed when final image is formed at D. That means least distance of distinct division. This is the basic discussion of compound microscope. Thank you.
Hello guys, I am Ranjan Mishra, and today we are going to discuss some numericals on compound microscope. Okay, see the question here. A compound microscope uses an objective lens of focal length 4 cm, that is f0 is given, f0 is 4 cm, and eyepiece lens of 10 cm, that means focal length of eyepiece is 10 cm. Okay. Now an object is placed at 6 cm from the objective, that is U is given, and that will be minus 6 cm. Okay. Now calculate magnifying power of compound microscope. In this question, it is not clearly mentioned that we have to calculate magnifying power for a far point case or near point case. So I am taking magnifying power for near point, and its formula is minus V upon U 1 plus D upon Fe. Okay. In the question we have U and Fe. D is, as we know, that final image formed at minus D and it is minus 25 centimeter. So you have to calculate only V, then we can calculate the magnifying power. We have the lens formula 1 upon V minus 1 upon U equal to 1 upon F. Here we are calculating for objective lens, so it will be F naught. Put the value 1 upon V minus 1 upon U is 6, so it will be minus 6 and 1 upon 4. Okay, now this minus minus it becomes plus. When it go to right hand side, it will be 1 upon 4 minus 1 upon 6. Okay, on calculating we will get V equal to 12 centimeter. Okay, we will get 12 centimeter. So just put the value and we will get the magnifying power MP. It is minus V is 12 and U is 6, 1 plus D is 25 and FE is 10. Okay, so we will get this is 2.5 plus 3.5 into 2, it will be minus 7. So the magnifying power of this question is minus 7. Good. Now in the next section it is said also calculate length of the microscope. Length means tube length. In fact they are asking tube length, and we know that tube length is V plus UE. Okay, V plus UE is the tube length. We know the V. If you calculate UE, then we can get the tube length. So let us calculate UE. 1 upon VE minus 1 upon UE will be equal to 1 upon FE. Okay, so 1 upon UE will be equal to 1 upon VE minus 1 upon FE. Okay, put the value 1 upon UE equal to, let's take here 1 upon UE equal to 1 upon VE. VE is minus 25 centimeter and FE is 10 centimeter. So it will be minus 10. So on solving we will get UV equal to minus 7.414 centimeter. So tube length L is V plus UE, numerical value. So we have calculated V, it is 12 plus 7.14, so it will be 19.14 centimeter. Okay, so finally we have calculated both magnifying power and tube length. Okay, let's have next question. Okay, now discuss the next question. In a compound microscope, an object is placed at a distance of 1.5 centimeter from the objective of focal length 1.25 centimeter. That means U is given and it is minus 1.5 centimeter. Okay, and objective of focal length, no, In compound microscope, object is placed at a distance of 1.5 centimeter. Okay, U is 1.5 centimeter from objective of focal length this. Okay, F naught. F naught is given 1.25 centimeter. If eyepiece have focal length 5 centimeter, that is FE. FE is 5 centimeter. Okay. Now, final image is formed at infinity and near point. There is two cases. In first case, final image is formed at infinity, and in second case, final image is formed at near point. Okay. We have formula for magnifying power for far point. Far point. Far point means when final image is formed at infinity, then we say that the formula will be minus V upon U into D upon Fe. That is, magnifying power will be minus V upon U and D upon Fe. This is for far point. Okay. Now, U is given 1.5 centimeter. V is not known in this question. D is known and Fe is known. Now we have the formula 1 upon V minus 1 upon U equal to 1 upon F naught. Okay, from here we can calculate 1 upon V equal to this will be 1 upon F naught minus 1 upon U, because this is minus it will be plus. Put the values. F naught is 1.25, okay, minus U is 1.5. On solving, we will get value V equal to 7.5 centimeter. Okay. So, MP will be minus 7.5 upon U is 1.5 and D is 25. The Fe is 5. Okay. So it will be 5 and it will be 5, 15, 5. It will be minus 25. Okay. This is for far point, and for near point we know that formula, it will be minus V upon U and 1 plus D upon Fe. 1 plus D upon Fe. So it will be minus 7.5 upon 1.5, 1 plus 25 upon 5. It will be 6 and 5, it will be minus 30. Okay. Done the question. Thank you. This month. Okay. Question is, the focal length of objective and eyepiece of compound microscope are 1.2 centimeter and 3 centimeter respectively. The object is at distance of 1.25 centimeter from objective. If final image is formed at infinity, magnification power of microscope would be. Okay, so let's discuss the question. In the question, see, the focal length of objective and eyepiece is 1.2 centimeter and 3 centimeter. That is f naught is given 1.2 centimeter and fe is given 3 centimeter. Okay, final image formed at infinity, that means ve is given minus infinity, and we know that in that case ue becomes fe, and in this case the magnifying power will be minus v upon u into d upon fe. Okay, now see here, d is known, fe is known, u is known. The object is placed at distance of 1.2 centimeter, that means u is known. So we can calculate v and put the values and get the solution. Okay, so let us calculate v. 1 upon v minus 1 upon u equal to 1 upon f naught, because this is image formed by objective. Okay, so the 1 upon v will be equal to 1 upon f naught plus 1 upon u. Put the value 1 upon v equal to f naught. F naught is 1.2. This is 1.2 minus, because u is will be in minus, it is 1.25. Solve this. On solving, we will get v equal to 30 centimeter. Okay, on solving we will get v equal to 30 centimeter and put this value in this equation. Okay, here is mp, it is minus v upon u d upon fe. V is 30 centimeter and u is 1.25, d is 25 and fe is 3 centimeter. It will be 10, and if I multiply 100, this decimal will be eliminated, and 25 5 and it will be 2, so final magnification will be 200. So option C is the answer. Okay, thank you. Hello guys, I am Ranjan Mishra and today we are going to discuss telescope. In this video especially we will discuss astronomical telescope. Okay, as we know that telescope is an optical instrument used to increase visual angle of distant large objects such as a star, planets, etc. Visual angle, as you have discussed in a microscope, that telescope and microscope both increases the visual angles, right? Again I discuss here basics of visual angle. If it is an object and here is eye, then angle made at eye, angle subtended, the appropriate word is subtended. Let the height of object be h, then angle subtended at eye is called visual angle. The purpose of telescope is to increase this visual angle, just increase. Okay, For this we define a term called magnifying power, as we have discussed in microscope section. Now in this topic we are going to discuss astronomical telescope. Astronomical telescope. Astronomical telescope basically have two convex lenses. Just like in a compound microscope, it also have two convex lenses. But difference is that the first convex lens is larger and second convex lens is smaller. So let's just draw the ray diagram first. This is the first convex lens and this is the axis, and second lens is smaller compared to the first lens. Okay, as we know, to draw the image, first draw the image and then just redraw the circuit, the ray diagram. Okay, let light passing like this, it will go to this and extended point will be in this section. Okay, let second light is passing through the focus. This is the F0. This is basically objectives because object is placed here, and this is eyepiece because eye is in this side. We have already discussed in compound microscope also. Light will go like this and the extended light will form image. Let it be here. Okay, this is the basic ray diagram. Okay, now let us make it as a theta, and this is theta naught. As we know that in telescope or in microscope we make first image in focal plane of second lens. First image by the objective is always made in focal plane of eyepiece, so it is the image formed in focal plane of eyepiece. This distance is V, and in general we take at the point of at a distance of F0. Okay, and this distance is UE, image object distance for eyepiece. Okay, now we can see here, let it be H dash. Okay, then theta will be perpendicular upon base, H dash upon UE, and theta naught will be H dash upon F0. It will be H dash upon F0. This is theta naught and this is theta. Okay, now we know that the visual angle for defining magnifying power. Magnifying power. Basically, we have to calculate magnifying power. This is the purpose of this derivation. We have to derive the magnifying power, and we know that magnifying power is visual angle with instrument upon visual angle without instrument. Visual angle without instrument. Okay, this is theta. This angle is theta, and this angle is theta naught. Okay, now we can write MP equal to theta upon theta naught, and theta is h dash upon UE, and theta naught is h dash upon f naught. Okay, but UE is in left side of eyepiece, so it is taken as negative. It will be negative. So MP comes out to be minus f naught upon UE. This is the general result of magnifying power. Okay, it is f naught upon UV. Okay, it is f naught upon UV. Now it is visible. So final, we can write that MP equal to minus f naught upon UV. This is the final result. Now we have to derive magnifying for two cases, for far point and for near point. Okay, now we have derived the magnifying power f naught upon UV. Now let us discuss two cases. First case, when final image is formed at infinity. This case is called far point case. Far point. In this case, I will be relaxed. In this case, I will be relaxed. Okay, that is final image. Final image is formed by the eyepiece. So VE is minus infinite. Now we have the formula 1 upon VE minus of 1 upon UV. It is minus, and 1 upon FE. As V is infinite, it will be 1 upon infinite plus 1 upon UE equal to 1 upon FE. So UE is equal to FE. And in this case, magnifying power becomes minus f naught upon FE. Okay, this is magnifying power for far point. Okay. Now second case, when final image is formed at least distance of distinct vision. Okay, that is VE must be equal to minus D. In this case, I will be strained. This case is called near point. Okay. Now we have the formula 1 upon VE minus 1 upon UV equal to 1 upon FE. 1 upon VE. VE is minus D minus 1 upon UV equal to 1 upon FE. Now 1 upon UE is equal to 1 upon D plus 1 upon FE. Magnifying power is F naught upon UV. This is 1 upon UV. If I multiply F naught in both sides, F naught upon UV, then it becomes F naught upon D plus F naught upon FE. Now MP, magnifying power, is minus F naught upon UV. Just take a minus sign and take F naught upon FE as common. So it becomes 1 plus FE upon D. This is the final magnification. Let me write here. MP equal to F naught upon FE 1 plus FE upon D. This is the final magnification in case of near point. Okay, this was the derivation of telescope, astronomical telescope. Okay. Hello guys, I am Ranjan Mishra, Revolution Physics Ghaziabad. Today we are going to discuss some questions on telescope. Here is the first question. The sum of focal lengths of the two lenses of refracting telescope is 105. The focal length of one lens is 20 times that of other. Determine the total magnification of telescope when final image is formed at infinity. Okay. Now we know that magnifying power is minus F naught upon FE in case of far point. Far point means when final image is formed at infinity. Okay. So if you want to calculate MP, we need F naught and FE. To calculate F naught and FE, information has been given in the question. That is the sum of focal length, that is FE plus F naught is 105 centimeter. Okay. The focal length of one lens is 20 times that of other. As we know that focal length of objective is greater in case of telescope, so F naught will be 20 times of FE. Now put this value in this, so it will be FE plus 20 FE equal to 105. So FE will be 105 upon 21 and it will be 5. So F naught will be 100. It is 20 times. So F naught is 100 centimeter and FE is 5 centimeter. Just put the value, that is minus 100 upon 5. So magnification will be 20. Okay. Let's have a question on a telescope. A small telescope has objective lens of focal length 150 centimeter. Okay, that means f naught is given 150 centimeter and eyepiece of focal length 5 centimeter. That means fe is given, this is 5 centimeter. If telescope is used to view 100-meter height tower 3 km away, find the height of final image when it is formed at 25 centimeter away from the eyepiece. This is 25 centimeter, that means it is a case of near point, and for near point we know the formula, it is f naught upon fe into 1 plus fe upon d, and this is nothing but visual angle with instrument upon visual angle without instrument. Okay, we can calculate first the magnifying power MP. It will be f naught minus 150 upon, it is 5, it is a 5 centimeter. Okay, and this is 1 and fe is 5 and this is 25, so it will be 655 and it will be minus 10. Okay, so 5 3 ja 30 minus 30 and 5 plus 1 6 upon 5, it will be 6, that is minus 36. Magnifying power is minus 36. Okay, now see the situation. The final image is formed at 25 centimeter. If this telescope is used to view 100-meter high tower 3 km away. Okay, now first image formed by eyepiece. Okay, let its height be h. This is the final height of image, and in the question it is 25 centimeter. That means this angle will be theta. That means tan theta equal to h upon 25. Okay, now image formed by objective. Okay, height of object is 100 centimeter and it is viewed from 3 km. That means it is 100 but it is 3000 meter. Then this angle will be theta naught. So tan theta naught will be 100 upon 3000. So it will be 1 upon 30. Now MP, we know that MP equal to theta upon theta naught. So it will be h upon 25 upon, this is 1 upon 30, and that is equal to minus 36. Already we have calculated the magnifying power. On solving this we will get h equal to minus 30 centimeter. Okay, thank you. Okay, here is the question. The diameter of moon is 3.5 into 10 to the power 3 kilometer and its distance from Earth is 3.8 into 10 to the power 5 kilometer. See the situation. Let us see. This is a moon, and it is subtending at angle at Earth. Let it be theta naught. Okay, this distance is given. So theta naught will be the diameter. Diameter is here is diameter 3.5 into 10 to the power 3 kilometer upon distance is 3.8 into 10 to the power 5 kilometer. So the theta naught will be 3.5 upon 3.8 into 10 to the power minus 2 radian. Okay. Now it is seen through a telescope having focal length of objective, that is f naught. F naught is 4 meter and FE is 10 centimeter. 4 meter and 10 centimeter. Okay. Now we have to calculate magnifying power of telescope. Okay. For normal adjustment, we have magnifying power as f naught upon fe. F naught is 4 into 100 centimeter upon 10 centimeter. So magnifying power will be 40. Okay. And length of the tube will be, second part we have to calculate length of the tube. This is the first part, this is the second part. Length of the tube is FE plus F naught. Okay, FE is 4 meter and this is 0.1 meter, so it will be 4.1 meter. Okay, now in third part, angular size of the image. Okay, we know that MP is theta upon theta naught. So theta will be MP into theta naught. MP is 40 and theta naught is 3.5 upon 3.8 into 10 to the power 2. Okay, it will be in radian. If you want to calculate into degree, we must multiply by 180 upon pi into 40 into 3.5 into upon 3.8 into 10 to the power minus 2, and it will be approximately equal to 21 degree. Okay, thank you. Let's have next question. An astronomical telescope consisting of an objective of focal length 60 centimeter. That means f naught is given, it is 60 centimeter, and eyepiece of focal length 3 centimeter, that is fe is given 3 centimeter. It focus on moon so that the final image is formed at less distance of distinct vision. That means for near point we know that magnifying power is f naught upon fe 1 plus fe upon d. Okay, So in this case it is 60 upon 3, it will be 1 upon 3 upon 25. On solving we will get 22.4. This is the magnification. But we know that magnifying power is visual angle upon theta naught. Theta naught is given as half degree. So final angle, final angular size theta will be mp into theta naught, and that is, if I take the magnitude, it will be 22.4 into half, then it will be 1.2 degree. If you want to calculate in radian, so we can convert 11.22 into pi upon 180, so it will be approximately 0.2 radian. Okay, linear size, we know that theta will be let the height of final image is h, then h upon 25, because image is formed at least distance, and theta is 0.2. So h will be approx 5 centimeter. This is the final result. Thank you.